Thank you, Michael. Okay, guys. Alright. These are just like the problems we did at the end of the notes that we kind of had a lot of trouble with. You guys remember those? Like, how does it change? We're going to do them mathematically, which takes a little longer, but it's easier. Okay. So it's just asking the current in the circuit increases or decreases or stays the same, and the voltage across the 8-ohm resistor increases, decreases, or remain the same. So we're going to calculate each of those things and see whether it increases or decreases. Okay, how do we find the total resistance in this circuit? Add them up, they're in series, we just add 6 plus 8. So RT equals what? 14 ohms. How do we find the total current in that circuit?
V equals IR.
V equals IR. It's going to be 24 divided by 14. And what's that equal?
1.71
1.6.
What is it, Chloe?
1.71.
amps.
0.71 amps. Okay. How do we find the voltage drop across the 6 ohm resistor? Since they're in series, what's the same across both? Current's the same across both since they're in series. So the current through the 6 ohm resistor is going to be 1.71 amps, and the current through the 8 ohm resistor is going to be 1.71 amps. And we're looking for the voltage across the 8 ohm resistor. I think I said 6 before. So we're going to do V equals IR. I is going to be 1.78 amps since that's the current across both. And the resistance is going to be 8. So what's the voltage across the 8 ohm resistor in this one? 13.68 volts. Questions on how I found any of those things?
The last one.
Last one?
Yeah.
Yeah.
We did the current through this one is 1.71, current through this one is 1.71. So we did 1.71 amps times 8 ohms.
Okay.
Yep, so we're finding the voltage across 8.
Gotcha.
Okay, how do we find the total resistance, the one where we added the 5 ohm one in parallel?
1 over 5 is
We're going to do this one first, so we're going to do R 5, 6 is 1 over 5 plus 1 over 6, and take the reciprocal of that.
2.72. No, 2.73.
2.73
Yes, sir. Ohms.
ohms,
Ohm that.
and then RT is equal to
10.73.
10.73 ohms. What's the total current in that circuit?
2.24.
Are you making it up? You know it for real?
It
No,
is,
it is
it is.
2.24.
Kyle's name then.
Okay, 2.24 amps. Now, how are we going to find the voltage across the 8 ohm one in this one? Same, exact same way. So the current through this whole thing is 2.24, and the current through the 8 ohm one is 2.24 since they're in series. So this whole thing is in series with the 8 ohm one. So the voltage across the 8 ohm resistor is going to be V equals IR, so 2.24 amps times 8 ohms. Voltage across the 8 ohm ones is 17 point something.
89.
89. Okay, so does the current increase or decrease? Increases. Does the voltage increase or decrease?
Increase.
Increases, so what's the answer?
B.
B. Do you guys see how to do that?
Yeah.
Is that easier than trying to figure out the other way?
What number are we comparing it to?
We're comparing it like this circuit to this circuit. So we're comparing the current in this one to the current in that one.
Is
Makes
this on the
sense?
quiz?
This is not going to be on the quiz though.
So,
It's 17.9.
it's 17.92, y'all, just FYI.
I didn't. I kept it in my calculator.
Can I erase this now, guys?
Actually, I mean, that's a good thing to do.
Yeah, but he always like.
You guys want to do number 2 together, or you want to try that on your own?
Let's do it together.
Okay, Michael.
I agree.
What would you do?
You ready for this one, too?
What?
Bad joke. So funny. You see the one Friday? So you just ready for this one?
Who comes up with the bad joke?
Various people come up with a bad joke.
That was so bad.
That's so fun.
That's
You're right. You see the one Friday?
No.
not even.
It's like,
Okay.
are you ready for this one? The answer is one.
Alright, so how do we find the total resistance of this?
1 over 15 plus 1 over 10.
1 over 10 plus 1 over 15, reciprocal of that.
Yes.
So what's that equal?
6.
Yep.
We did it.
Alright, 6 ohms. How do we get the total current?
Equals IR.
5.
Yeah, it was wrong.
What? I don't put like
So current's 5 amps.
I don't say that. I leave.
What we're looking for here, guys, is the current through the 10 ohm resistor and the current through the 15 ohm resistor. So you need to figure out if that's going to be the same, different, or decrease. Okay. So what's the voltage across each one of these since they're in parallel?
The same.
The same. What is the number though?
30.
30. So the voltage across 10 is 30. So for the 10 ohm one, it's going to be 30 volts equals the current in 10 times 10 ohms. So what's the current through the 10 ohm one? 3 amps. And for the 15 ohm one, it's going to be 30 volts equals I for 15 times 15 ohms. I for 15 is 2 amps. What do those two add up to? 5. So our total current's 5. The current in each branch has to add up to that.
Oh my, who's doing that?
It's the middle table that have fun with
Okay, Michael, stop.
This symmetry.
Okay, how do we find the total current in this one? And the RT is going to be the same from 15 and 10 are going to be 6 from before. Add 5, so what is it? 11 ohms. What's the total current?
2.73 amps.
2.73 amps. So now we're going to find this one gets a little trickier because we need to find the current through both of these. Before we do that, we got to find the voltage drop across this because there's one in series now. So we're going to find the voltage for 10 and 15 is going to be equal to 2.73 amps times, what's the total resistance of 10 and 15? 6. Times 6 ohms. 16.38 volts. Okay, now we're going to find the current through 10. So the current through the 10 ohm one is going to be, since it's 16.38 volts across the whole thing, 16.38 volts in that one, 16.38 volts in that one. So it's going to be 16.38 volts equals current of 10 times 10 ohms. And what's the current through 10? 1.64 amps. Same thing for 15. We do 16.38 volts equals current through 15 times 15 ohms. What's the current through 15? Okay, so for the current through 10 and 15, does it increase or decrease? Decrease. Do you guys see how to do these with math? It takes a little longer, but it's Might make a little more sense to some of you guys. Answer C. Yep.
Will we have one of these on the quiz?
There will be one of these in the quiz tomorrow anyway. Eventually there will be.
Alright.
But
Can we take a test?
tomorrow's a quiz. We're gonna take a test eventually over this stuff.
Can we do the ones that will be on the quiz tomorrow?
We're gonna do ones that will be on the quiz tomorrow now. Okay, can I erase this?
Very unsightly.
The worst last name
Alright, we'll do number 3 and I want to do number 4 with you guys because it's slightly different than the ones you've been doing. Or do you want to do number 4 first?
4.
Let's do 4 first. This is number 4 on the sheet.
Let's do this.
You're the one who's been doing that.
Never done it.
Joke. So good.
Okay, so we're looking for the current and voltage through R3 up there. What's different about this one, do you see how it's just one big parallel thing? So our last step is going to be finding something in parallel to find the total resistance instead of series like it has been before. It's going to change something very slightly. It actually makes it a little easier, to be honest. We're going to start out the same way. We start off writing R3 equals 18 ohms, and then we're only going to include resistors in this like kind of list here that R3 is a part of. Anything else we're going to include over here. So what's our first step going to be? Combine 3 and 2. So we'll say R23 equals 39 ohms if they're just in series. Then 2 through 4. So you got R2 through 4. What's that equal? 1 over 39 plus 1 over 5. And the reciprocal of that.
4.4.
Okay? And then, what's next?
Then we find out 4 or 1 to 4.
Yep, so series with 1, so 1 through 4. And that's going to equal 7 plus 4.43, so that's 11.43 ohms.
I understand that.
Alright, everybody okay with those? And everybody see how 3 is a part of each one of those? Okay, what's next? Combining 5 and 6, is that going to be over here underneath? Underneath because R3 is not a part of 5 and 6. So we do R by 6 is equal to 21 ohms if they're just in series. What's after that?
Find the parallel of 1 through 4 and 5 and 6.
No.
Nope.
7, 8, 9.
We're going to do 8, 9, and then 7, 8, 9.
And then
Then do the
1 through
parallel of
4,
R3.
Oh, okay.
Okay.
That was planned.
You said 8 and 9?
8 and 9. So what's 1 over 11 plus 1 over 8. It's gonna be around 5, I think. 4.63 ohms.
No, yeah, 11 and 8.
And then what is R7 through 9 gonna be?
25.63.
That's what I had.
25.63 ohms. Okay, so now, to find our total resistance,
I had 5.74.
so total,
Oh, sorry.
okay.
Jumping the gun.
So we have to do all 3 of these parallel branches together. So we're gonna do one over R1 through 4, 1 over R5 and 6, and 1 over R7 through 9. So we're gonna do 1 over 25.63 plus 1 over 21 plus 1 over 11.43. Take the reciprocal of that. So what do we get for RT?
5.74 ohms.
What was that?
5.74 ohms.
5.74 ohms. Okay, Abby?
Okay, so you do 1 over 25.63 plus 1 over 21
Yep.
plus 1 over 11.43?
Yep.
Okay.
And you want to make sure you do that all in one step. What you'll get messed up on is if you take like these two, like find the R of 1 through 6, and then find the whole thing. You need to do any parallel or series thing all at once. Does that make sense to everybody?
Yeah.
So don't do this in pieces, do it all at once or you're going to mess yourself up for over here. Okay, since these start in parallel, we're going to not start with current. What stays the same in parallel? Voltage. So we're going to start with voltage. What's the voltage across this whole thing? 36. So that means the voltage through each branch is 36. So the voltage to this top branch is 36 volts. So when you start off in parallel, you just write V equals 36 volts. Now we have the voltage across the top branch that R3 is a part of. Now we need to find the current through that. What 2 things we're going to use to find the current? Voltage and resistance of that whole branch. So it's going to be 36 volts equals the current from 1 to 4 times 11.43 ohms. And the current from 1 to 4 equals what? 3.15 amps. Sarah?
How come you do it on the bottom, like with the total and the total one before?
Because it starts out in parallel. So like this part right here is what you're asking about, right? We could have found the total current in the circuit and we would have backtracked and gotten 36 volts for the voltage again.
So it like eliminates a step basically.
It basically eliminates a step.
That's cool.
Because the voltage across the top branch is 36. So if it's just one thing in parallel at the end, then you just write down the voltage. Okay, now we need to find the voltage drop across this, and that's going to be the voltage in that top branch. So what resistance are we going to use to find that? 2 through 4. So the current through that whole thing is 3.15. So we're going to do voltage across 2 to 4 is equal to 3.15 amps times 4.43 ohms. And what's that equal?
13.95.
13.95 volts. Now we're going to find the current through that whole top branch, and that's going to be one of our answers because that's going to be the current through R2 and the current through R3. So we use the voltage we just found, and that's the voltage to that top branch. So 13.95 volts equals I2 and 3 times 39 ohms. And what's I2 and 3? 2.80?
No.
0.36.
0.36? Okay. Questions on that part? So that's the current through the top branch, so that's one of our answers because that's the current through R3. And now I gotta find the voltage across R3. So last step is V3 equals IR, so 0.36 times 18 ohms.
6.4.
Alright,
No, we didn't.
Brian,
Why did you find RT?
we didn't have to find RT.
So you can just find the top part.
You can just find the top part in this.
So we didn't have to do any of the other
You
stuff.
didn't have to do any of the other stuff.
So I did.
So you could have stopped here, but that's all we used in the problem. We didn't use RT. But a lot of times, this is more similar to what we did in the past if I include RT and just go over to voltage. Anybody have any other questions over this
So
one?
what's the voltage answer?
The voltage is 6.48. Alright. Everybody okay with this one? Do you guys want to do 3 together?
Let's try that.
Yeah.
Yeah? What?
Number 7.
Number 7 is just like number 4.
Literally.
Hey, so I hear you guys want to do, at least some of you want to do 3 together.
On the quiz, I have to find like the voltage and current like of all of them.
I'm not going to put on all of them on the quiz.
Thank you.
Including precursors.
So, like, some of you guys want to do 3 together?
Can I try it? You might have to analyze my work and figure out where I screwed up.
Okay, how about for number 3, you guys try it on your own and I'll just write out the answer up here.
Sounds good.
Sounds good?
Alright, now we're done.
So, be quiet at least.
Okay, I need to write this out. What's the same for current?
Series and series.
What?
Series.
And then parallel. In a series of things in voltage, or in parallel, the voltage is the same. No. In a series. In a series, the current is the same. In parallel, the voltage is the same.
No.
What just happened? I'm really confused.
Can I ask a question?
Yeah, go ahead, Michael.
So, like, since it's not all in parallel, we need all the resistances this time?
Yep, since it's not in parallel, we gotta start with RT this time.
What do I find? Okay, what do I find? So since so it's going 1.3 what's in full top line.
Hey, Mr. Tete.
Yep.
Why will it mess it up if you don't do like one where it's like a block and then a block like underneath that? Why would it mess it up if you don't do it all?
Which one I
You can do it in separate steps,
I can only use this one.
but it'll
So then
mess
I
up
say-
the method I do this for you.
Of like fine.
So there's nothing wrong with it, but finding it is where it's gonna mess it up. So like to find the total resistance, that doesn't matter.
Right.
But when
You try and do.
when you try to go back, you're gonna have an extra step in here,
Okay.
and that's
then
gonna mess up everything. Yeah.
Okay. Okay.
So the voltage. Yeah.
Alright, so there's the answers. Do you guys have any questions, or you want a minute before you?
Can you
Yeah, I'll wait a minute.
right, and then you just have to find the voltage again. And then just voltage.
Are these gonna, how many of these are gonna be on the test tomorrow?
There's gonna be 2 total resistance ones that just find RT,
Uh-huh.
and 2 find the individual current through resistor.
Are they gonna be as bad as like that last one on the quiz? Like,
No,
where
there's
it's
gonna be-
16?
Like the total resistant ones, I feel like you guys can find pretty much anything, no matter how complicated I make it. But for the current and the voltage through a resistor, it's going to be more like number 5 on the sheet, something
Okay.
of that level.
Alright, thank you.
Does anybody have any questions over this now?
Yes, Dad.
You guys all okay?
Are you talking British accent? No, Mr. Tente. We're fine.
My cousin goes to English school. His dad was an actual back talking.
Abby?
Okay. I did. I got.
Where are you getting 7.45 volts?
7.45 volts.
Are you like working kind of backwards?
That times that, yeah. So I'm working kind of backwards. So that 7.45 comes from here. That's the voltage across this whole piece. So that means it's the voltage to that top part. So let's have that voltage to the top part. Find the current in the top part using R34 and that voltage, and that'll give us the current through that top branch.
So you don't have to technically look at the whole thing. You only have to look at that little part.
You only have to look at the things that R4 is a part of to find the current voltage through it. So like the current through this doesn't really change anything about R4 once we found the total.
But you technically have to do everything because you have to find.
Yeah, like this does affect what goes on in R4, but to actually find what it is, you only need to use the things that R4 is a part of.
So all of them are going to look pretty similar to these.
Yeah.
And define the voltage in 4, how do you know that you had to do 3 through 6?
To find the voltage in 4, 3 through 6, because 4 is a part of 3 through 6.
Okay.
So like, we didn't have to do 1 and 2 because 4 is not in that, but 4 is in 3 through 6. Right. Is everybody done with this one?
Yay, I got it.
I just get confused on like, okay, I get
Might
kind
as
of
well
fine
do
with
a serious
resistance and
statement.
stuff. I get confused when like,
Backtracking?
yeah.
Do you understand like
That part confused.
why we use these ones? Like why these ones are here?
Yeah, I understand why those are there, but in the other column, that's
Okay.
the whole thing I don't get.
Alright, so for the first one, if it's in series, we find the total current. If it's in parallel, for like if RT was like if we did the one guys, quiet. If we did the 1 over thing to find RT, we do voltage here. But since we did just series, we added them all up to find RT. We're gonna find current here because current's the same in series. So we do the voltage of the battery times the total current times the total resistance, and that's the total current in our circuit.
Okay, so this is different from number 4, because number 4 you wanted to find.
Number 4, it started off like the last thing we did was find the parallel,
Where are you getting 33 from?
the voltage of the battery.
Oh.
So once we have that, that's the current through each one of these pieces. It gets divided up into branches, but through that whole thing, the current is 1.13 amps. Then we need to find the voltage drop across that whole big piece. So the voltage drop is going to be different because they're all in series, so we've got to find the voltage if they're in series. So we use the current that's through it and the resistance of that whole piece to find the voltage across that one.
Okay, and that's across the top.
That's across this piece right here. At 7.45 volts. So if there's 7.45 volts across the whole thing, that means in each individual branch there's 7.45 volts.
Okay.
So through the top branch here there's 7.45 volts, and that's the one we want to worry about since we're looking for R4. So we're going to use that voltage and the resistance of R3 and 4 to find the current through that top branch. So we do V equals IR again, we get I equals 0.19 amps, and that 0.19 amps goes through R3 and R4 since they're in series. So that's one of our answers. So the current through R4 is 0.19 amps. Then we need to find the voltage drop across that, and it's going to be 0.19 amps times 14 ohms to get how much the voltage drops across that one. So those are our 2 answers. Does that make sense?
Yeah, I think it's just like memorizing which one comes next. Like,
And it's always going to alternate current, voltage. So it always alternates between the two, and it should always be getting progressively smaller
okay.
as you go through. Right, any other questions on this one? Michael?
Just as like a general pattern, when you're working backwards, does it always go current, voltage, current, voltage?
You just
It
said
goes,
that.
Oh, sorry.
it goes current, voltage. If you, the last thing you did was find a series thing. If the
Okay.
last thing you did was find parallel, it goes voltage, current.
Okay.
Does that make sense? Sean?
What's the answer number 5?
Answer number 5 is 0.25 amps and 3.47 volts.
Yay.
Okay, I'll put the answers out over here.
Close.
So if we can do all these, we're good for the